For those online, we just finished part one. We're running about 10-15 minutes late here. We're going to go right through part two, which is about the life cycle and SEPS, and then take a break. This is about the space and equipment planning system, the work done for VA, Department of Veterans Affairs, and Department of Defense military health system, the strategic plan, proofs of concept. We'll touch on the macro BIM pilot for VA as well. One theme throughout all this is there's a lot, VA and DoD together have a huge portfolio, 210 million square feet, and I mentioned this earlier, that even though they're this large and they do have a system SEPS that's been in place for many years, they still aren't, they realize they're still not large enough to solve this problem alone. That's why all of the results of the strategic plan are being shared publicly in the hope of getting the message out there, and also the second objective is to try and find other potential partners, whether other government agencies, other healthcare organizations, or even other non-healthcare organizations. It's a very similar pattern that we're seeing regardless of the type of owner that's there, including back to the California community colleges. As in our work at Onuma, we see that it's a very similar pattern, no matter how large or how small an owner is, or the pattern is very similar about what's trying to be solved if you're looking at managing facilities. So at the core level here, the space and equipment planning system, SEPS, just went through a transition this year, actually, before we even got involved with the project. It was already being moved to what's called SEPS 3.0, which is web-enabling SEPS. SEPS used to be pretty much a desktop application that you installed on a laptop. You went to a hospital and you interviewed the hospital, the clients, the team, the stakeholders at the hospital, and asked them how many patients do you have, how many procedures do you have, and you have these inputs, these rules into SEPS that says we have this many patients, this type of procedures, and it outputs essentially two Excel files. Excel file for a program for design that says here's how much space we need, and a second Excel file which is the equipment list. And then that gets handed off to the design teams, who then take it into their applications. And in the past, obviously before BIM, even with BIM now, a lot of this transfer of data from the Excel file into BIM, there's a lot of automated tools out there that can do that right now. But it's still kind of you're passing it over the fence. You're saying essentially, here's an Excel file. The original criteria of what drove this Excel file is in SEPS, and now we're taking it out and now we're designing it. And the challenge is that, as we all know, as a project moves through, the original requirements get shifted, the budget gets shifted, things change, so you end up with delays, you end up with cost overruns, square footage, equipment missing, and there's reports out there about the challenges that are out there in that current process, which translates into millions and millions of dollars. We had many discussions with groups. Balfour Beatty actually gave us some great case studies of what typically gets run into in the field as far as the challenges of delivering on a healthcare facility using these outputs. So what we were brought into is to look at, okay, SEPS is being moved from 2.0 to 3.0 in 2013. Just this month it was put on last month on max.gov. Beyond that, what else can we do rather than just web enabling, rather than just turning the switch and making it web enabled? And that's what this SEPS strategic plan project was all about. I ran over this earlier about the White House digital strategy document. We spent a lot of time saying, how does that relate to SEPS? And we said, in SEPS, it's the current version of SEPS is tightly bundled. It has data with the application bundled with the interface. We are recommending to split that apart, to basically take and web enabling it, and also having a security layer, which is now on max.gov. The login, basically, we didn't have to build a new security layer for that. It's on max.gov. The next step on it, is to actually have the information layer, the data, accessible as a web service. It's taking the data and completely what's called decoupling it from the application. In other words, we're not dependent on SEPS to manage the SEPS data. It's decoupled, which means others can actually use it to create solutions, whatever they might be. There's some immediate ones that we've identified and also future ones that might not be planned for. And then the SEPS platform that says here are the rules of how you get to the data, the APIs, the web services of publishing out how you equally get to the data. And the other very important piece is whether you are the presentation layer, whether you're a COTS, commercial off-the-shelf application, or a government application, the rules are going to be exactly the same. If you want to work with SEPS, here's the web services to get to SEPS, which opens up to other vendors to create solutions and say, hey, we have a solution that can link into SEPS and create different kind of value. and then the industry, the customers are able to interact with that. So that actually increases the number of users. That was the last slide there. The number of users increasing actually the client base essentially of people that can actually touch the application. Right now it's kind of frustrating because you have to be trained in the use of SEPS and then it takes a while to get trained. It's not a simple process. So we're saying if we make it simpler to use and more users touch it, that by default makes it more valuable and helps SEPS and the data and it evolve. So that's one of the main concepts that you'll see running through the whole strategic plan. So Lifecycle, end-to-end, we did a lot of slicing and dicing. I'll go into a little detail. It's kind of hard to read here. I'll have other slides here. But essentially we're saying all the data, the types of buckets of data, if we decouple them and make them accessible, then it's going to be much more efficient. For example, right now, one of these says equipment standards. There's an equipment standard that say here's all the medical equipment that DoD and VA use. And the way it's distributed right now is a DVD is burned and distributed out to everybody, and then you install it on your system and you use it in different ways. Very 1990-ish kind of. It was okay back then. It's completely unacceptable today. It just doesn't make sense. Very expensive to maintain and use and update. As soon as you get it, it's out of date, all that kind of stuff. So that's the opportunity that exists of taking that data and making it more efficient. So these are the stages that we were in. We just transitioned into SEPS 3.0. Web enabling, it just happened in June, which is on max.gov. Our next phase, we're saying, and it's still tightly coupled as an application kind of with the data, we're saying the next step is to decouple the data. Take the data out of the application and let the application, the SEPS application, subscribe to that data. And SEPS 3.2, then we're saying once you completely decouple it and you make it web service enabled and you have a platform, you can have other applications directly tying into it, whether it's an application that a software vendor creates, or whether Balfour Beatty has an application that can interact from their design and construction perspective to tie the data directly into them, so we don't have to do this passing back and forth. It's going to change. That's the next kind of phase, the sequence of things that are going to happen. There was this diagram from the Department of Defense as far as the life cycle. The stuff on the left is the equipment data I was talking about, is the 1691. SEPS is in the middle, kind of consuming that in the programming phase. Then their view is to how do we get this data into the life cycle, and that's the next stage. The part 3 presentation is going to be about that, but it's really about how do we move data across these silos, which today are very fragmented, very inefficient, very expensive, and really not scalable. Basically, it's collapsing on itself as you start trying to stack different things on top of each other. Now, one thing that we were tasked with in the project was to look out to the industry as well, to look what solutions exist out there today that can tie into the system. So not just talk in theory about, well, this is going to be great when we get here, but say, well, here are solutions like max.gov, like other vendors, them applications, how they tie into it. So it was not just a theoretical, here's where we want to go, but actually show proofs of concept, and not necessarily to say this is the only solution, just to say, yes, it's actually possible if you decouple the data. So in order to do that, we also went through the whole process of what SEPS does right now. It's a little bit hard to read, but essentially it's before SEPS is updated periodically, and to do that you have to get, for example, the latest type of, what's the latest medical equipment out there. It has to be analyzed, put into that DVD, distributed by the DVD, inserted into SEPS, create the application, and then maintain and manage those standards. So there's a lot of stuff happening here about keeping that up to date, which is what Andy kind of touched on as well too. It's very disconnected from the workflow. It's a separate workflow of keeping things up to date, whereas if you say, let's make it part of the workflow, we can make it more efficient as far as updating the information. So there's SEPS committees and criteria managers that take this data and crunch it through and put it into the application, and then the application is used to output data. So we're kind of going through, that was the criteria management of the requirements going into programming the requirement for a healthcare facility, then being passed off to the design team. So there's a lot of stuff happening within here. And along the bottom we're saying, what happens if this data is web service enabled and we can access it on max.gov? What kind of interactions can happen between these different phases rather than manually passing it over the fence each time? And there's a lot of opportunity there. If you even took one piece of this, there's a lot of places that this could become more efficient. In the design and construction process, there's a lot of stuff that's happening in building smart alliance about standards and COBE and IFC. There's opportunities there as well, but it's not just that. There's also the connection to web services that we saw as a potential savings there in time, budget, and accuracy. And then the final handover of how do we take the final construction data and push it back into the life cycle. And there's different types of needs of the type of data when it goes into the life cycle as well too. So each of these phases, there's different stakeholders, and we tried to say each user that touches the data has a different need, and they might not, like I mentioned earlier, the facility manager might care less about 3D or BIM or structured data, but they need to fix this work order that just came in. They need to get to the piece of data that's very similar to the data that might be used for design and construction, but here's a space, here's a piece of equipment. So if we take that data and make it accessible, different types of use will come out of that naturally from different vendors. So the two choke points, the two main choke points are going from programming into design, and then the design team, the architects and builders take over with that, and then it's passed off to operations. The main problem is that the data right now is actually you're relying on the design team to pass the same data that started in programming and facility management, and those two sides don't talk. They're completely different systems. They don't talk to each other. So there's no real way of automatically validating that we have the right requirements in the building now. So massive amounts of data moving through a project, and that's, again, an opportunity of how do we make that more efficient and break down these choke points and not have this disconnected process of managing files and passing files back and forth, but making it machine-readable data to get to this life cycle view. One other thing that we also identified was that the knee-jerk reaction in the past has been to create these monolithic systems that do everything, and you keep on adding more and more features, everything doesn't do everything that everybody wants, so it doesn't really work completely. By creating this kind of modular approach, you can have, if you disconnect the data at the bottom and you have different types of uses. I need to analyze a floor plan, for example. I want to look at a floor plan. Well, an executive level person might want to look at it and say, what's going on with the plan of this facility? And the contractor might also want to look at the same floor plan and say, how much square footage do we have? The same type of use, but the same type of data, but a different type of use, a different type of interface. So we're saying if we split it off, there's different levels of users. Those users, a lot of them just want to get to the data. How do we get to the information? There's some that want to interact and comment on the data. And there's this third set, essentially, that actually edit and update it. And if you make that part of the workflow, as you're editing the data, it should be made accessible to the executive level team, for example, that wants to see the information. If I go back to Yelp again, and Andy touched on this as well too, if Yelp had to be published quarterly and say, well, here's the great restaurants in DC, which was a norm before, right? Let's buy a guidebook. It was fine for that moment, but it's meaningless today. If you say, well, that restaurant, the hours are wrong, or the map is wrong, or the menu is wrong. We start expecting more from that, and that's where the opportunity is with this as well too. If we look at the whole life cycle of how do we publish the data consistently for many different types of users. So these are the steps. 3.0 was currently implemented. We're heading towards 3.1, 3.2. We put a very aggressive schedule to the timeline because a lot of this development in the past used to take months or years to do. 18 months was kind of the norm for software development. Now a lot of these applications can be done in a very short time period if you don't have to build stuff from scratch. So we're saying once that's enabled, you can start moving a lot faster. So we put a very aggressive time schedule for that. There were numbers, preliminary budget numbers associated with each of these phases, and I'm not going to go into all the details here, but how do we go phase by phase into this agile development, testing and implementing and adjusting so you don't end up 18 months out and realize, hey, this is the wrong application we built, which happens a lot in government. You realize after 18 months, wow, we've just burned through millions of dollars, and wow, we just throw it away and start over again. That's no longer acceptable because there's better ways of doing that. How to more efficiently manage requirements. I'm going to keep on touching on the equipment requirements. The 1691 bubble that you see on the upper left is that DVD that I talked about that's distributed. If that was a database and it was web services and we could all access it, we could say, what's the current list of equipment that is used by VA and DoD? We should be able to access it from SEPS or from other BIM applications and use that in our design and construction, and then also into operations. So we had a lot of proofs. These are actually functioning proofs of concept. We had 12 functioning proofs of concept that were documented, and they're online. Ultimately, the decisions and the data that we decide on projects ultimately ends up in a place like this. So it's massive amounts of data. It's big data. We just can't get to it today. It's out there, which means it's a resource and it's an asset if you can get to it. If you can actually manage this and get to it, it becomes an asset for an organization rather than a liability. So one of the proofs of concept, we said, it's as simple, and again, start simple. You don't have to eat the whole elephant. BIM is great, but if we try and say the way to solve this problem for VA and DoD is to have a high level of detailed BIM for everything. Well, that's not going to solve it. We have to get there in stages. The high level of detailed BIM is good for design and construction, but right today, and this is not just VA and DoD, challenge on VA and DoD, this is actually almost industry-wide. What number is this room and how many square feet do I have? Just as simple as that. It's kind of a location-based thing. And in our work with macro BIM, it literally was months to get to, well, what is this surgery 123 or is this residency 286? A lot of scribbles and a lot of running around buildings and interviewing people. So that list of where are the great restaurants in this area on my iPhone does not exist in the facility world today, more or less, except in the California community colleges. They've actually nailed that for 120,000 spaces. Therefore, they can start stacking other kind of functionality on top of that. So we said, for SEPS, this is a functioning proof of concept mobile app that was developed pretty much in a few days that says, if you have SEPS data and it's accessible, we can create a mobile app on an iPhone. You can pull up that standard on an iPhone, which today is not possible. So it's literally a few days worth of development that can happen. And we'll show this later as well. That can cut literally months off of the time on a project like this. So the whole concept of the Agile approach, the traditional method, the waterfall method, 18 months versus very short bursts of development that can get recycled. And not only get recycled, but get thrown away. If something doesn't work and you've only spent a few days on it, it's actually okay to throw it away. When you've spent 18 months on it, it's very painful to throw it away, although that's what happens. So these are some screenshots of the current version of SEPS that's running on max.gov. This is live now in testing and development and training, I believe, for the users. Contractors also use SEPS as well, so it's not just government-centric. The first version of it is still kind of centered around the access levels that were in SEPS 2.0, but our hope is that as SEPS development moves on, and I'm a consultant, Balfour Beatty or another design build team, whoever, or I'm a vendor and I want to get to the SEPS data, I can create applications and get to it and do stuff with it. Okay, so the proofs of concept, there were 12 developed. Number one was let's figure out how we're going to do security access, two-factor authentication, and that was on max.gov. That actually got implemented before this report was even completed of how you would actually log in. So once you're logged in, then you can get to the data. So knowing who you are lets you access the type of data that you have in SEPS, and these other ones are about decoupling, creating templates, managing the portfolio, all these little snippets of things that were not just theoretical, these were actually functioning proofs of concept that were developed, making it universally accessible, creating an ecosystem, having mobile applications, and how do you partner with private healthcare. This is number 12 about partnering with private healthcare is important because once you decouple the data and you make the data accessible, all of a sudden that engine, that SEPS that's specific to DoD and VA could be used by other healthcare organizations, for example, and replaced with their data, and the engine would still be there. So just to give an idea of the number of data points, it's just infinitely complex because there's, these are a little bit hard to read, but there's 808 room types in SEPS, you know, exam rooms, operating rooms, whatever. And the number, there's typically 50 pieces of equipment per room, and there's attributes per piece of equipment. So even if we had a BIM of every one of these rooms saved as a BIM, it would, and something needs to be updated, it's just a massive amount of work to keep it updated. So it has to be part of the workflow. As new equipment standards come in, we want to flow it right into the BIM. It has to be published out and subscribed and accessed by the BIM to be used for the life cycle. So if we publish it as web services, we said in this proof of concept 2, then you're able to get it into an iPad. That was the iPad and iPhone prototype that we built. And you can get it into a Revit model or another BIM application as well. That data should flow all the way through. You shouldn't have to copy and paste it each time and then hope that it all lines up. So that was one of the proofs of concept. You know, we have many different tools. And again, I want to also stress that the applications that we use were not necessarily to say, well, here's the application you should use to do this part of the process. It's more about, well, here are examples of what already exists out there. to encourage other vendors to jump in and say, hey, we have a similar solution that can plug in here. So it should literally be a plug and play. Well, we have many options here. It's not just one. So the SEPS data flowing into the applications. Then if we think in terms of, okay, now we have this whole system that's an engine that defines requirements. If here we have a hospital and projects are being run through every day. What happens when a standard changes or a piece of equipment changes? That should flow automatically into, if I push a button and I output a BIM, it should have that data that's the latest piece of equipment information, which is not happening today. It's a combination of out of SEPS and in PDFs. In some cases, there's standards that are published online and that are not always consistent with what's inside SEPS. And then as changes happen, that red box there is kind of showing what happens next year when a new piece of equipment comes in. I don't want to have to rebuild the whole system and save all these files out again. So 808 room types, and as changes happen, we want to track those, and we don't want to have PDF files, for example, in the future, which is what was published right now. There's PDF files. What Andy talked about data flowing into reports, we shouldn't be saving reports as files and documents that then get distributed, because that's not how we, I was using the airline reservation system, that's not how we reserve flights. We don't go to Expedia and print out today's schedule and come back next week and buy a flight, which is what we're doing right now in the building industry. So again, another opportunity there. How do we solve that? The levels of detail, we don't need highly detailed models to start having discussions about how many pieces of equipment and what's the cost and what's the attributes. You can start with simple blocks and then replace them as you go along. You can automate a lot of that. There's tools out there today that take data and automatically create BIMs, objects, rooms, and equipment in it. We're saying if you refine this process, it's going to become easier to start maintaining that. So we have to start building this engine that starts feeding in on itself to maintain and update these standards. This is one of the proofs of concept automatically generated. This is actually using Revit and the Onuma system, but other applications can do the same thing, basically taking data and creating this mixture of blocks and spaces automatically, and using Webservices. So within the BIM application, you don't embed the data into the object, but you can actually go out and subscribe to get me the latest data about this piece of equipment. So if the manufacturer changes their information, it flows back in. The portfolio. It was important, even from a SEPS perspective, we realized that SEPS is about the project, but also it feeds into, now we have a portfolio of facilities that could be used to, now we need to renovate it or start a new project. So it's important to think of this in terms of the life cycle. It's not a single event of designing and constructing a project, but it has to make its way all the way through and even feed all the way back to a single piece of equipment, saying here's the piece of equipment in the space that ultimately started from the SEPS output. So the current process, as I talked about earlier, is the Excel files get passed to a designer. The designer puts it, researches that and finds what's the latest standard for designing a hospital or a healthcare facility. Goes and grabs PDFs and Word documents of specifications and manually brings that all together. We're saying if we automate this process, all of a sudden all that tedious work should go away, and we should just focus on the design work and not have to kind of make sure that things are in alignment. And also, as it goes back to the owner, to be able to track the difference between here's what we asked to build and here's what we're getting delivered, and now it's actually in operations. Here's the same piece of equipment as we're in operations. We talked to eSpecs. This is just one example of a company that has a database that tracks to the specifications for a project. Right now it's kind of going, the designer goes through and puts it into a BIM, and then they have the specification tied to the BIM. We're saying that if SEPS outputs that data in an open format, you can start getting the floor finish, for example, in the spec in the early stages before it even touches BIM, and then track it through the BIM as it goes through. So a lot of, again, a huge amount of data kind of passing through this. This is a proof of concept with using DProfiler, Beck Technologies, and the programming data making its way into a DProfiler to do early blocking and stacking of the model, and then tracking it through to other detailed models of design and construction, to Revit in this case. So status quo, a lot of uncertainty, and how do we collect this particular project? It was literally months to kind of collect, well, where are we starting? What do you call things? How many square feet of space do you have in this existing facility as we're doing the renovation? Very, very tedious process. Naming standards varying all over the place. A lot of Word documents, data being captured in Word documents, for example, and then having to be transferred to BIM. We estimated, we had to do a lot of ROI calculations of how much does it cost currently and what's the potential savings on single activity. So it's tens of thousands of dollars all over the place of manually managing documents like this. So quickly, there's a few slides here on the macro BIM project. Renee, would you like to say anything about this, or should I just breeze through it? Okay. So the macro BIM project was separate from the SEPS project. It was happening in parallel pretty much. It was to look at the output from SEPS and identify ways that this data can be used to define and do blocking and stacking and what-if scenarios and early cost estimating and site analysis with the SEPS data. Here's SEPS coming in from the upper left. So we actually used Excel files, for example. We prototyped that process. It was with Beck Technologies and Onuma system, DProfiler and Onuma combined, using XML formats, for example, to share data between the different systems to do rapid prototyping of buildings. And then also just looking at the ROI. We kind of looked back on that and said, okay, this particular process, if we had access to the SEPS data directly, we actually parked it in a server and we pushed a button and output a building, versus the 3 months it took to go and collect what exists out there. Literally 3 months of people on the ground kind of saying, what's this room called, all that stuff. That happens on pretty much, a lot of owners are running into this right now. You're basically having to reverse engineer what you already have paid at one point in the past, whereas really it should be at your fingertips. We should be able to walk around in the room and say, well, what room number do we call this? And that's a big challenge, just that consistent naming and numbering. Just naming and numbering of rooms, just not even going to OmniClass or BIM or anything. Just naming and numbering rooms is a huge challenge. Therefore, even if we have a perfect BIM and you don't have a consistent room numbering, and we identified this years ago with Coast Guard work as well too, it's a non-starter because all of a sudden you're spinning your wheels talking about room numbers. So with SEPS, we're saying if this is made consistent, all of a sudden this data just starts flowing. So we had this engine kind of going, so what if this happens? iPads, iPhones, BIM, same data in different formats, the data inside the BIMs, now we can design with that. Then it ends up in the construction as well. I think that's the next leap, right? Getting that model into the actual as-built and then managing that from a facility management perspective. So here's the functioning proof of concept. We'll demonstrate that after lunch or during lunch, some live demonstrations of what that looked like with the smartphones. And just using QR codes, for example, and scanning a piece of equipment and that data coming up directly on the iPad. So mobility is becoming the norm. That's almost expected. There's really no way around this. This is where we have to go. The industry's already there. So how do we bring the kind of the app economy, the free or the low-cost applications that do very powerful things, focus on specific tasks, to be able to do things like log in, find my room, view information, put a comment on the room, and move on. And then even give that application to the doctor that's in the room, the occupant, saying, well, this piece of equipment's old. I want to put a comment in so it doesn't get designed again, which happens today, actually happens quite a bit. A piece of equipment gets delivered that's already obsolete by the time it's in the room. Multiple platforms. I'm kind of breezing through this because I want to get to the break here, and then we can go into discussions after if we get the audio going here. And, oh, Mo, you brought your Google?
Oh, yeah.
Okay. This guy has Google Glass. I've never actually seen Google Glass in real life, but imagine all of this, what we're talking about. Mo, from the consultant for the State Department. We all introduce ourselves, but he has Google Glass. It's already coming our way really fast. It's already there. So why can't we get our facility data into something like this? Imagine being able to just walk around, and that technology is already upon us. I'm sorry. Maybe Mo, you can do it quickly. What is Google Glass? I'm here because we have the audio here.
So it's pretty much a phone. It's pretty much a phone right on your face, right? So you get messages, One of the things that it does is videos, pictures, take pictures, videos, and then also we're kind of building enterprise solutions using APIs. And solutions for healthcare, solutions for aerospace, and things like that. One of the really cool things that we're working on is notifications and information. So if you're in a particular room and facing a particular specific direction, you can say, oh, you've got so and so asset here, and this is the year, and even print stuff out. That's a complete solution just out of hands-free device. For doctors, they can use it for emergency ER. I've got 6 patients. Give me notifications for what's happening to those 6 patients while I'm doing something else. For operation, you can have multiple screens. Usually doctors, when they're operating, they're looking at different screens. We can project some of those screens on vision glass and share it. With aerospace and public safety, there's a lot of different solutions as well. With public safety, Department of Homeland Security has something called PPE. These are what they try to do is make it easy for people to go out. So if firemen and police officers are out on the street, firemen could probably get a blueprint of the building that they're going to be going into and see the evacuation routes and the elevators, the place where the fire is in particular, how many people in different rooms, and so on and so forth. So those are some of the enterprise solutions that we're kind of looking together.
Can you prepare to demonstrate what, show us what you're seeing?
Yes, so right now I can use my phone to actually show. Right now the way Google provided this, they've only given out like about 2,000 plus globally. Our company got quite a few because we're really closely working with them as partners to deploy these solutions. Yeah, I can definitely do it on the next one.
Yeah, maybe for the last, if you're here around, we have a demonstration.
Yeah, and yeah, it kind of shows up on the phone. If you have an Android device, whatever you're seeing can show up on the phone.
So imagine this with all your facility data as you're walking around. It's location aware too, right?
Yes.
So this is already in development, and the developers building solutions that are going to be public, and basically you don't have to carry a tablet around or phone around. This wearable computing that's happening. I think the building and facility industry is perfectly suited to something like this because it puts us on site. And that
Well, as you say, it's hands-free, so you could have instructions about what to do with your, working on something.
Right.
It's nothing technology. The military, when they work on the Apache helicopter, have things on display and the whole name and the parts and systems of the Apache.
Right.
Or the jet fighter, or the nuclear submarine.
Right. Actually, I'm going to hold the comments because you can't be heard online, but you said basically that the military is using this for Apache helicopters. So
Not Google itself, but
they have their own, yeah. So the military's been using it for years as far as the heads-up display. And you were with NSA with it?
Oh no, we were working with
I know,
George.
just kidding.